This is section 4.1, part A, degrees and radians. An angle are two rays that meet at a common endpoint. So if we have one ray that starts here, remember a ray has one point, extends indefinitely in the other direction, and we have another ray and they meet at a common point, then we form an angle. That common point in which they meet is called the vertex. Now another way of thinking of an angle is to draw the first ray, and then you are just going to take the ray and you're going to rotate it around that point, and wherever you stop will be the second ray that forms the angle. If you form an angle in this way, the first ray that you draw is the initial side, and where you stop rotating is called the terminal side. Now if we do this in the rotation form and we have an initial side and a terminal side, if your initial side starts at the origin and your initial side is on the x-axis, on the positive x-axis, then we know that our angle is in standard position. If we measure our angle counterclockwise, you start from the x-axis and you go to the left, the angle will be positive. And if we go from the right, it will be negative. Now, the most common way to measure an angle is in degrees. There are 360 degrees in one circle, and remember we measure this counterclockwise. Now, when you are in degrees, you can write this as a decimal form of degrees, or you can write it in degrees, minutes, and seconds. In 1 degree, there are 60 minutes, and in 1 minute, there are 60 seconds. So if we have it in decimal form, you need to write it in degrees, minutes, and seconds. And if it's in degrees, minutes, and seconds, we need to write this in decimal form. So to do this, if it's in a decimal form, whatever is in front of the decimal is just your number of degrees. Now you're going to take the decimal part and we're going to multiply it by 60 because we know there are 60 minutes in 1 degree. And that's going to give us 44.1 minutes. Now we're just going to take the part in front of that decimal. That's how many total minutes we have. We have 44 minutes, but we still have that 0.1 minute. Now we know there are 60 seconds in 1 minute. So if we multiply that 0.1 by 60, we will get that there are 6 seconds. So 56.735 degrees is equivalent to 56 degrees, 44 minutes, and 6 seconds. Now, if your angle is given in degrees, minutes, and seconds, we can work backwards to find the decimal form. So we're going to start with the seconds first, and we need to convert that to minutes. To do that, we're going to divide by 60, and we're going to get 0.46 repeating minutes. Now we're going to take that and add it back to the minutes we already have. So now we have 5.46 repeating minutes, and we can divide that by 60. And that'll tell us how many degrees we have, which is 0.091 degrees. And we can take that and add it to our actual degrees and write this in decimal form. Now another way to measure angles is to use radians. Radian is measured in what we call theta, and to find this, we take the intercepted arc that is formed by that angle, and we divide it by the radius of your circle. So S divided by R will tell you how many radians or theta you have for the angle. The most common radian measures, one whole circle, remember, is 360 degrees. In radians is 2 pi. Half of a circle, or 180 degrees, is pi radians. A quarter of a circle, or 90 degrees, is equal to pi over 2 in radians. Or a sixth of a circle, or 60 degrees, is equal to pi over 3 in radians. Now, if you need to convert from degrees to radians, you would multiply by pi radians over 180 degrees. And if you convert from radians to degrees, you would multiply by 180 degrees over pi radians. So if we convert these, I'm going to write this over 1 Because degrees is on top, we want the degrees to be on bottom. So I'm going to have pi radians over 180 degrees. Now we can do this because remember, pi radians and 180 degrees are equivalent. So this is just like multiplying by 1 over 1 because they are equivalent to each other. Now we can simplify what goes into 120 that also goes into 180. We know that 60 goes into both of these. 60 goes into this twice. 60 goes into 180 3 times. Now we can multiply straight across. 2 times pi gives me 2 pi. 1 times 3 gives me 3. So it's 2 pi over 3 radians. If we do this for the next one, again, we're going to start by writing this over 1. Again, the degrees are on top, so we're going to put the degrees on bottom, and we'll put the radians on top. 45 goes into itself once. 45 goes into 180 4 times. So negative 1 times pi is negative pi. 1 times 4 is 4 radians. If they give it to you in radians, we need to convert these to degrees. So instead, you're going to multiply, since the radian or the pi is on top, we need to put the pi on bottom. And we're going to put 180 degrees on top. Now we're still going to simplify first. So I have a pi on top and a pi on bottom. Those are going to cancel, leaving you with 1 on the bottom. 6 goes into itself once, and it goes into 180 30 times. So if we multiply across, 5 times 30 gives me 150 over 1, or just 150 degrees. If we multiply again by 180 over pi radians, because the pi is on top, we put the pi on bottom. If we cancel, the pi's will cancel, leave me with a 1 on bottom. 2 goes into itself once, goes into 80 90 times. So negative 3 times 90 gives me 270 over 1, or negative 270 degrees. Now, two angles are coterminal if their terminal side is located in the same position. Now, it is possible that you have a positive and a negative angle that are coterminals, or you can have two positives that are coterminals. So this is about 210 degrees. So on the positive, that would be 210. A whole circle is 360. So if I've already used 360, how many are left going the opposite direction? So this would be a negative 150 degrees, the opposite direction. Those are coterminal because they end in the same place. Now let's say this is 60 degrees. So alpha is 60 degrees. It could have a coterminal if you do a whole circle and then do the extra part. So that would be a whole circle is 360. Add another 60 degrees, and that would be 420 degrees. And they still end in the same place. So those are coterminal angles. Now, to find coterminals, if it's in degrees, you can add whatever your angle is. You can add 360 times n, where n can be positive or negative. That's just how many times you go around the circle. If it's in radians, you're going to take your angle, and you're going to add 2n pi, because remember, one whole circle is 2 pi. So we're going to identify all angles that are coterminal with the given angle, then find and draw one positive and one negative. So for all the angles, it's just going to be 45 plus 360n. That would be for all the angles. Now, if we draw 45 degrees, it would be right here. This is 45 degrees. So we need to find one positive and one negative. To find a negative, we can do 45 plus 360 times negative 1, or just 45 minus 360. And if we went clockwise instead of counterclockwise, the negative angle for this would be negative 315 degrees. To find a positive coterminal, we're going to do 45 plus 360 times 1, or 45 plus 360, which would give us 405 degrees. So if we start here, we still go counterclockwise. We'll do one whole circle, and then we continue past it until we get to that terminal side. That would represent 405 degrees. We need to identify all the angles that are coterminals and then find one positive and one negative angle. Again, we're going to do negative pi over 3 plus, this time it's going to be 2n pi for all the angles. Pi over 3 is located right here. Now, to find a negative coterminal, this is a negative pi over 3, not a positive pi over 3. So let's change our picture. Negative pi over 3 would be right here. So to find a negative coterminal, we're going to do negative pi over 3 plus 2 times negative 1 times pi, or negative pi over 3 minus 2 pi. Now to be able to add fractions, we need them to have the same denominator. So if this is negative 2 pi over 1, we can multiply the top and the bottom by 3, so they have the same denominator. 2 times 3 gives me 6 pi over 3. Negative pi minus 6 pi gives me negative 7 pi over 3. So we would still go clockwise. You would do a whole circle, and then you would continue on until you hit that terminal side, which would give us negative 7 pi over 3. To find the positive coterminal, we're going to do negative pi over 3 plus 2 times 1 pi, or negative pi over 3 plus 2 pi. Again, we can write that as 2 pi over 1. We still need to get the denominators the same, so I can multiply the top and bottom of 2 pi by 3. So this will give me negative pi over 3 plus 6 pi over 3. Since the denominators are now the same, we can add the numerators. This will give us 5 pi over 3. So we would start and go counterclockwise until we hit that terminal side, and that would be a positive 5 pi over 3.